So, the next series of video we are going to discuss about design patterns. This is important concept and important topic that needs to be learned at the early stages of software development field. There are many reasons for that. We will try to cover each design pattern in a detailed manner in the next series of videos. So first, we will try to relate this design pattern with the real-time example. So many people used to tell that the best time to have lunch is between 1 p.m. to 2 p.m. and the best time to have dinner is 7 p.m. to 8 p.m. so that we can have a good dinner. So similarly, software experienced people usually says that we need to follow these design patterns to make a software reliable and to make a software to make a program in a performance way. So we need to follow these design patterns to make our software best work. So that's our motto. That's our motto behind this design patterns. So the definition for design pattern is they represent the best practices followed by experienced software developers. So software field is in movement from the last 20 years. So from that time, people used to see the many use cases. They used to solve those real world problems using some solution. So that software experienced people trying to group those solutions into a single to a templates. So templates means in this case design pattern. So if there is some common solution for n number of problems, means they will try to treat it as a design. So we need to follow that design if our use case falls in that category. So that's the power of this design pattern. If we learn this design pattern, then we can easily relate any real world problem with the existing design pattern. If there is no if a use case doesn't match with the existing design pattern, then we can create our own design pattern and we can publish our design pattern to the external world. So that's the power of this software design. That's the power of this design patterns. So this is targeted to solve the problems of object creation and integration. So if you consider a software object-oriented programming, then the first thing that comes into the mind is object creation. So if there is an object, means there are many things that are related to this object. So object creation, initialization, object communication, like that. So everything will be handled in this design patterns. We will try to cover all the design patterns using some real world example and using some programs in the upcoming videos. Please try to watch all the videos in this playlist. And the design patterns act as templates for the real world problems. So I have already explained about this in the previous context. So if there are n number of solutions, if suppose there are n number of use cases, if n number of use cases can be solved by a single problem, means then that is the template, that is the design pattern. So we can use that design pattern to solve our real world use cases also. So we need to first relate our use case with the existing design patterns use cases. If we can relate that our use case with the existing design pattern related use cases, then our problem is solved. So this was discovered by the 4 people, Erich, Richard, Ralph and John, and they published a book called Design Patterns, Elements of Reusable Object-Oriented Software in 1994. So this book covers 2 things. The first part covers pros and cons of object-oriented programming, and the second part covers 23 design patterns. So actually, the first part was covered by many books, but the second part is a unique one. At that time, these 4 people stands out from the other people. So the reason behind that is the second part, 23 design patterns. So these 23 design patterns falls under these 3 categories: creational design pattern, structural design pattern, and behavioral design pattern. So under creational design pattern, it covers object creation and initialization. For example, in case of software object-oriented programming, we need to create some objects for our real-world use case. So object creation, and then we need to communicate with the object from other objects. So that would be handled using creation design pattern. And then comes the structural design pattern. Structural design pattern is we have some interface like USB interface, and we have the implementations for USB. So we need to decouple. We need to loosely couple this interface and implementation. If your software or modules are loosely coupled, means then your software is more reliable and more outstanding from other things. And then third one is behavioral design pattern. So if suppose this is a class and using this for this class we have created 5 objects, means if suppose these 5 objects needs to communicate with the class thing, so the communication between class and object would be handled in the behavioral design pattern. So we will try to cover every design pattern in the upcoming video to discuss about model view controller. So this is the important topic for the next series of videos. Gang of Four, as a Gang of Four, I've invented the software design patterns, 23 software design patterns. They use this model, this as base for those 23 design patterns. So you can imagine the importance of this concept. So this is a theoretical one. So please try to watch this video fully, because I will try to relate these theoretical concept with real-time examples so that it won't be very boring. So model view controller. So what is the main aim of model view controller is decouple the things. So consider a train. So for each train there will be n number of compartments. So one compartment is linked with another compartment with some iron rings. If there is any problem in a compartment, then we can easily decouple that compartment and we can put a new compartment. We can attach a new compartment to the existing compartments. So that's the power of decoupling. So here the compartments are individual units. So each individual unit is linked to another individual unit using some coupling factor. If all the compartments are bundled together, means then we can't decouple them. So similarly, in our program we should write our classes in such a way that we can easily decouple the classes. If we write like that, then the code would be reused in n number of times and we can easily manage the code. That's the core concept of model view controller. Here there are 3 things applying for making this theoretical approach to be practical. The first is model, second view, and controller. First we'll discuss about the view. If you're trying to open a college portal and you're trying to give some roll number. If you give some roll number, then you will see the details of that corresponding roll number. The data that you are viewing is the presentation layer or view layer. So that view layer may be different from each application to another application. If you are using Google Analytics, means you would see pie chart, bar chart like that. If you are using some online site, means you would see some filters and some products like that. The things that you are seeing is the presentation layer. It depends. Every application has its own presentation layer. So screen presentation. For example, pie chart, bar chart, and etc. And then next comes the controller. If you're trying to give some roll number, here the roll number would be sent from the client to the server. That would be managed by the controller. So it acts as a mediator between the model and view. Okay. So here view is a presentation layer where we are giving a roll number. That would be sent to the model via controller. We will discuss about the model in the later part of this video. And then it defines the way the user interface reacts to the user. For example, if you are using Paint application, if you have observed it clearly, then you will see that if you are based on a mouse actions, the actual drawing would differ. Here, the user actions are captured by the controller, and based on user actions, it's doing some operations. That's the second point. Defines the way the user interface reacts to the user. So this is done by the controller. So next one comes to model. So model is the holder of the data. For example, if you consider student data, means the student details like roll number, names, and marks, grades, all would be encapsulated and stored in a single object that would be managed by the model. So, and it also manipulates it. For example, suppose if I'm trying to change the phone number means, I will try to give that request via the view layer. That view layer captures the data and the data would be sent to the model via controller. So the controller is the player who acts as a mediator between view and model. And then model gets that request and it will try to update the existing phone number with a new phone number. So that's the first one, holds data and manipulates it. Example, student object holds name, marks and etc. So this is the basic main concept for the next series of videos about creational design patterns in a brief manner. In the next series of videos, we will try to cover each design pattern which falls under creational design patterns in a detailed manner using real-time examples, real-life examples and also using some practical implementation. So please try to subscribe my channel and try to watch all the videos in the upcoming days. So first statement is deals with object creation mechanism. So if you are writing any program using object-oriented programming language, then you must create some objects. At some cases, the object creation will be very easier. At some cases, it will be a tedious process. So it depends on the use case. If you are creating a complex object means, you should follow some mechanism in such a way that it could be reused for other purposes and it can also be managed well. So that would be categorized, that would be handled by these creational design patterns. There are 6 creational design patterns which solves each use case. So if a use case falls under a particular bucket, then you need to pick the best design pattern among these 6 design patterns. So we will try to discuss about these 6 design patterns in a brief manner. In the upcoming video, we will try to explore the design patterns in a detailed manner using real-time and real-life and implementation. So create objects based on use cases. So here there are 6 design patterns. For example, abstract factory. We should use abstract factory design pattern only if it falls under this category. Suppose if there are n number of families. For example, animal family. Under animal family there are many classes like dog, cat, like that, and we have another family called insect family. We have some classes like ant, like that, and human family. So based on input, we need to, this abstract factory will try to return the best object based on the input. So suppose your use case falls under this category, then you need to use abstract factory design pattern. So we'll try to cover each design factor in the upcoming video. So for now, just treat it as a brief introduction like that. And then comes to builder design pattern. So builder design pattern means we'll try to create an object from the base or from the scratch. Factory design pattern, it will try to create an object. Using several derived classes. It will try to pick the best derived class and it will try to return the object for that class based on the user input. And then object pool. The main principle of object pool design pattern is to recycle the objects that are already created. And then prototype. Prototype means copy or clone the objects. Singleton. Singleton means only one object creation for the entire JVM process, life cycle. So these are the 6 design patterns. If your use cases falls under this category, then you need to pick the best design pattern among these 6. Reduce the complexity of object creation. So actually, object creation is a tedious process, and then managing the objects is also a tedious process. So everything would be managed by this creation design patterns if we follow a proper structure, and it will also reduce the complexity and then define the best possible way to reuse the object. So we have created an object by using n number of resources like time, memory and etc. We need to reuse it. If we follow these categories, if we follow these patterns, then we will try to reuse the objects already that I've already created, so that our code would be in a very efficient manner, so that we can save various resources and we can serve n number of clients in a particular amount of time. So please try to watch the next series of videos so that you get the complete detail about the software design patterns. We are going to discuss about Singleton design pattern in a theoretical manner. In the next video, we will discuss about the Singleton design pattern using some programs. So this video is all about theoretical and real world examples. Next video is all about the program. So first, what is Singleton pattern? So the name itself suggests that there is something, there is a single, only one thing. That's a Singleton means there is something that is which stands alone for one time. So here Singleton means only one object. So only one object creation is one allow. If suppose if you are trying to create multiple objects for the class, JVM doesn't allow that. JVM allows only one object creation. That object would be reused by n number of times. That's the power of Singleton. So you just imagine a scenario. If suppose if you are trying to create an object n number of times means, for example, consider that n equal to 5. So this is in memory. If you want to create 5 objects means first object, second object, third, fourth and fifth. So 5 objects consume some considerable amount of memory that can be avoided using Singleton. But there are some rules. There are some rules when we should use Singleton and when we shouldn't use Singleton pattern. The first rule is, if suppose some objects has its own properties or own things means we shouldn't use Singleton pattern. For example, consider this case: student Lenny equal to new student 1, 100. 1 is the roll number and 100 is the marks. Student Chenchu equal to new student 2, 100. Here Chenchu is the object, 2 is the roll number and 100 is the marks. Here 1, 100 is the specific properties or the specific properties for Lenin object. 2, 100 are the specific properties for the Chenchu object. So we shouldn't use Singleton for these use cases, because if suppose if the object has its own or specific properties, then we shouldn't use Singleton property. If object has its common properties, if suppose an object doesn't have any specific properties means, then we can use a Singleton pattern. For example, we will try to cover that example in using real world examples in the later part of this video. So we will try to cover advantages of a Singleton design pattern. Since since JVM is allowing only one time object creation, then it is trying to save the memory. So in the previous part of the video, we would have discussed that if suppose if you want to create 5 objects means, then it consumes 5 object memory. But JVM allows only one object for Singleton, so only one object. So the remaining 4 object memory can be reused, for other purposes. So it saves memory. The second point is performance improvement. So performance improvement in this sense, for creating object, it needs some amount of CPU. The object consumes that memory and performance improvement. So these are the two major advantages, the main advantages of using Singleton design pattern. And then we will try to cover this implementation details in a detailed manner in the upcoming videos. For now, just consider that if you want to implement Singleton pattern means, then the class constructor should be private. So we would have discussed about the public constructors in the previous videos, but to implement Singleton pattern, the class constructors, all the constructors should be private. So that's important point. Now we will try to cover this part in a detailed manner using programs in the upcoming video. Please try to take a brief thing from this part, and then real world examples. So many have asked me regarding the Java course. So they ask me, why can't you teach me Java course? So I said that I have already spent a lot of time and effort for making a course, Java course. I hosted the Java course videos on YouTube. So please try to go and watch that video. So here, that JVM is the environment. I am the object. So many people are trying to ask the JVM to create new object. But JVM is saying that already one object is created that can be reused. So please try to reuse that like that. So I am the object. So only one object is created. That one object is reused many times. So I am the source for the object. So I am my object. I am is my only one time object creation, so only one time I'm going to post the video. That video is watched by n times. So n times is the n number of times, n use cases where that object help is needed. So here the object don't have the specific properties, so it has a common property, so it can be used by any number of times. That's the real time use case of Singleton. And then Java has many Singleton implementations. One of the important implementations is runtime class. So runtime class is the Singleton design pattern implemented class. So only one object is created for the JVM. So you can use n number of times. So if suppose if you are trying to ask to create a new object, means it will try to give the already created object. So this is the real-time use case where Java is using Singleton design pattern. So thanks for watching this video. Please try to watch the next video also, because in the next video we will try to cover, we have covered the practical implementation of Singleton design. Now we are going to discuss about factory design pattern. So this falls under creational design pattern. That is, in big entities, the motto of creational design pattern is to create object and also to initialize the objects. The same motto is for also, the same motto falls for the factory design pattern also. Factory design pattern also tries to create an object and also it initializes the object. So here the definition for factory design pattern is create object without exposing the creation logic to the client. So if suppose I am the customer or consumer, if I'm trying to buy any soap from this shop, so I'm trying to approach the shopkeeper. I'm trying to ask, I need Amam soap, I need Rexona soap, I need Lux soap. The shopkeeper analyzes the request. So and the shopkeeper decides which soap needs to be returned. So that's the factory. Here the shopkeeper is the factory. So we will try to relate the next example with the factory class. So phone manufacturer. If suppose I am the phone manufacturer, I need OS for various phones. I don't have any knowledge about the OS, but I need OS for iPhone. So I'm just asking the OS factory that I need OS for iPhone. So OS factory analyzes that the OS for iPhone would be iOS. The OS factory returns iOS to the phone manufacturer. Now the next time the phone manufacturer is approaching the OS factory and the phone manufacturer is asking I need OS for Samsung phone. The OS factory now analyzes, since the request is Samsung, it will return the Android OS. Okay. And then the next time the phone manufacturer is approaching the OS factory and then he is asking I need OS for Nokia phone. Now the OS factory is written in the Windows OS. So according to this example, the phone manufacturer doesn't have any knowledge about the OS. So the information that the object creation is hidden for phone manufacturer. For him, he needs just an OS for that phone. So that request will be handled by the OS factory. So this is the factory. So here the object creation is done using the input. Input is iPhone, Samsung, Sony. So based on the input, the best object would be returned. This is another example. And another example is, if you are working in a software company, then you would have you would have noticed this kind of scenarios. For example, there are a number of clients, bank client and some small shop client. If suppose a bank client is coming to the manager and is asking some UI developer, best UI developer for some contract purposes. So manager analyzes the resources means UI developers. So he is trying to analyze the UI developers and he will try to pick the best one out, best from among these UI developers for the contract job. After some time, a small shop owner approaches the manager and he is asking that I need some UI developer, but I will pay only less amount of money. So manager analyzes that request. So that here the criteria is less money and UI developer. So he uses those two criteria for picking the UI developer. So according to these examples, the client doesn't have any knowledge regarding the UI developers. He needs just UI developer based on some criteria. That manager handles those criteria and returns the best object for those criteria. So here manager acts as a factory class. So this is another example for explaining the factory design pattern. In the upcoming videos, in the next video, we will discuss about how to write a program using factory design pattern. Now we are going to discuss about abstract factory design pattern theoretically, and also using some real-time examples, and also using some code snippet. In the next video, we will try to explain this abstract factory design pattern using some program, using Java language. So please try to watch that video also for better understanding. So here, first, what is abstract? Abstract means hiding. So for example, consider a real-time case. If you want the fan to work, what will you do means you will try to put the fan switch. Here, you don't know what's the technical things that is happening behind the fans working, but you are getting the actual output. You need the fan to work. That's it. The technical inner details are hidden from the actual client or customer. So that's the meaning of abstract. And what's a factory? Factory means it's like a provider. For example, if you have some problem, medical problem. For example, if you have fever, means what you do means you will try to go to the nearest medical shop and you will try to tell your problems. So like, I have some fever and cold, so I need some best medicine. That medical shop owner or medical shop member or representative will try to analyze the problem, and he will try to, or he or she will try to return the best medicine possible. Here, that medical shop representative is the actual factory. The factory provides the object based on. So here types of fever, cold, like that. So this is the meaning of abstract and this is the meaning of factory. So what is the abstract factory meaning? So here abstract factory means super factory which creates other factories. So we have already covered about the factory design pattern in the previous video. Suppose if you haven't watched that video, please try to watch that video and then come to this video for better understanding. So what super factory? So for example, consider another example. Here consider I am the soap manufacturer company. I need to manufacture some soap. So what I will try to do is I will try to divide my company into n number of companies, n number of factories to be exact. So one company tries to manufacture wrappers, the soap wrappers, and the another company tries to manufacture the soap raw materials, and the another company tries to manufacture the other raw materials. The fourth company will try to combine all the raw materials and try to produce a soap. So here actually there are 4 factories which are working under one single factory. So that's one single factory is called super factory or abstract factory, that will try to manage or it will try to pick the requirements from the clients or customers and will try to return the appropriate factories. So the super factory will try to get the output from all the factories and it will try to make it as a final product and will try to release like that. So that's the gist of the abstract factory design. We will try to explain that using this real-time example and also using some code snippet. So this is a real-time example. So I have classified animals into 2 types, domestic and wild. Under domestic category, cat and dog belongs to the domestic category. Lion and tiger belongs to the wild category, wild animal category. So actually, technically, animal is an interface. So it has a method called public int get number of friends. The actual implementation for that method would be present in the lion concrete class, tiger concrete class, cat concrete class, and dog concrete class. These classes would return the actual number of legs. For example, cat, dog, lion, tiger, all of those have 4 legs, so it will try to return the 4 legs. If suppose if some animals have 6 or 8 legs, means it will try to return the number of legs. So this is the actual example. So these classes would be managed by the domestic animal factory. For example, if a customer is going to a shop, if a customer is going to the medical shop and is trying to sell his problems that I have some cold and I have fever, but medical shop representative would return some appropriate medicine. Similarly, client or customer is going to a domestic animal factory and is trying to get some domestic animals. So the client is telling that I need an animal of 4 legs of weight 25 kg. So you will try to return the dog object because that would be the more appropriate when compared to cat. Similarly, for a wild animal factory, based on the requirements, it will try to return the appropriate object. So the requirements are 4 legs and 50 kg. The appropriate object would be lion or tiger. It depends. These two factories will be managed by the animal factory. So animal factory is the abstract for these to the outside world. To the outside world, it doesn't know whether there's an animal factory, wild animal factory or domestic animal factory. It's very abstract. So the requirements for this animal factory would be, I need a wild animal, first requirement, and then the the number of legs should be 4, and the weight of that animal should be less than 100 kg. Based on these 3 requirements, this animal factory would process those requirements and will try to choose the appropriate abstract factory, appropriate factory. So here the wild animal factory would be the more appropriate factory, and it will try to wild animal factory try to return the appropriate object for the criteria. The appropriate object would be lion, like that. So this is the abstract thing. So similarly, if you can say another real-time example, this is the medical representative. So if I am the customer, I am the person who is going to the medical shop and I try to ask that I need a medicine for cold, fever, age is 25, like that. Based on this requirements, it will try to choose the according factory, whether light fever factory or heavy fever factory. Using the light fever factory based on other requirements, it will try to return the appropriate medicine. So we can relate n number of examples using abstract factory design. The actually abstract factory design is implemented in Java libraries. So if you are trying to read some XML files using DOM parser, then you would have used the abstract factory, because document builder factory is an abstract factory. Using this factory, you can get the actual factory object. Here, the actual factory object is docfact by calling get instance method. Using that actual factory object, you can get the concrete objects. Here, using new document builder, I am getting the concrete object for this docfact object. So using the concrete object, we can do n number of operations. So this is the real-time example. This is the code snippet where abstract design pattern was implemented in Java library. Please try to watch the next video also, because in the next video we will try to explain how we can implement the abstract factory design using a simple case from Let's Make Learning Simple channel. Now we are going to discuss about prototype design pattern. So actually the name itself conveys that it's a prototype. There is some virtual thing, by using that we can create the actual things. For example, if you are building a new house, then there is some prototype. Using the prototype, you can use the prototype design to create the actual object. So it falls under creational design pattern because it plays its role while creating the new objects. So create new objects by cloning or copying. This is the one statement that defines the meaning of this prototype design pattern. Suppose if your application needs n number of objects of the similar object means, then you can create the object for only one time, and you can clone or copy those objects for n number of times. By doing that, you can save time and also memory and also computation power. So these are the two real-time examples where prototype design pattern plays a major role. For example, suppose if a Java application is trying to read the data from database, example name and weight of a dog. So that the database will return the name and weight of the dog XYZ and 10 kg. Using this information, Java creates an object for dog. So that object is called dog object, name XYZ and weight 10 kg. If a Java application needs the same similar kind of data and it needs to create a similar kind of object, means there are two ways. One way is the Java asks the database once again, it will return the same data and it will try, Java application will try to create the same object. That's the one way. So suppose if you have 100 objects requirement, means then 100 times database call will go. That's very costly operation in terms of time and in terms of competition. So we can do in another way by using this actual object as a reference. We can copy this object to n number of times. Technically it's called cloning. So if you want to tell in layman terms, it's just copying. So using this dog object, we can create dog 1, dog 2, dog 3, n number of dogs by consuming less amount of memory and also less amount of resources. And the second example, if you are a user, if you are trying to download a movie from the internet, if suppose the movie name is Mr. Bean movie, what you will do is you will try to download from internet. So it may, if the size of the movie is 1 GB, means it may take nearly 30 minutes for downloading that. After 30 minutes, what you do, if you have watched that movie, means you will tell to your friends that the movie is very nice. So what your friends will do is, your friends will also ask you regarding that movie. So what you do is, you will try to copy the existing movie either to pen drive or DVD or disc, and you will try to give it to your friends. This is also a prototype design pattern. Here, you are trying to copy a source to a number of virtual things so that you can save the memory. In this case, you can save the data and also time. So thanks once again. In the next video, we will try to explain the prototype design pattern using real-time examples using Java code. Now we are going to discuss about object pool design pattern in theoretical way using some real-time examples and using some Java-oriented implementations in a detailed manner. In the next video, we will discuss about object pool design pattern using some sample code. So we will try to implement the object design pattern using some real-time example scenario. So first, what is object pool? So actually pool is a collection of something. If we consider swimming pool, it's a collection of water where n number of people can swim at a particular time. Similarly, object pool is a collection of objects. So n number of clients can be served by that object pool at a particular moment. So first, object pool design pattern falls under creational design pattern. The reason behind that is this design patterns, it comes under the stage during the object creation stage. That's the reason why it falls under creational design pattern. So this pattern falls only at the object creation time. And the second point is reuse the objects that are expensive to create. So this statement would be explained using this real-time example and the Java-oriented real-time example. So this is a real-life example. If you are studying if you are doing engineering, means then you would have to write exams for the 8th semester. So nearly 8 semesters. So for each semester there would be n number of papers. So for writing the exam, you would try to study a number of books for one particular paper. Some people would find it difficult to buy those books because the books are very expensive. At that time, what they would do is they will try to get the books from the library. So if I am that person, I will try to get the books that require books from the library. So after that semester, I will try to return those books to the library. So here I am trying to get the books from library. So library is serving us. After finishing our job, we will try to return those books to the library. Then library uses those books to serve other people. So here the books are the objects. The books are getting reused. So instead of buying the books, we are trying to get books from the library. After finishing our purpose, our job, we are trying to return those books so that the library representative will reuse those books and that library representative will serve many people. So that's the real life example where object pool design pattern is implemented. And the real time example where object pool design pattern is useful in Java. If there are n number of clients, nearly 1000 clients. 1000 clients are trying to create a database connection pool. So if you create a one database connection pool itself, it's a very expensive object because it involves n number of resources. If suppose 1000 clients are creating this similar kind of object means, then the expensive would be 1000x. So instead of that, what we'll try to do is we'll try to reuse the object that were already created by someone. That's the person is called reusable pool. This reusable pool, what it do is it will try to create some object, some limited object. It will try to manage the clients. For example, if suppose 4 clients are asking the objects means, this reusable pool size, this reusable pool will try to serve those 4 clients. This reusable object pool will act as a manager for the objects. So it will try to it will try to get the used objects from the clients, and it will try to give those objects to the clients who are aspirant to get those objects. That's the power of this reusable pool. So these are the advantages when we use this object pool design pattern in our code. The first advantage would be boost the performance. So since the object creation is a costly operation, in some cases, when you consider database connection pool, it's a very costly operation. Since we are reusing these objects, we are trying to improve the performance. So it will boost the performance automatically. And then it saves the memory. For example, if suppose n number of clients are using n number of objects, means that n number of objects would occupy some memory. Since we are using the object, that it would implicitly save some memory. And then it reuses the objects, it saves resources also. Because to create an object, it needs some n number of resources. Since we are reusing these objects, we are trying to save the resources for some other purposes. These are the advantages. There are other advantages are also applicable for this object pool design pattern. We will try to cover those things in the upcoming video when we try to implement the actual. When we try to implement the object pool design pattern using some real case scenario. So at that time you will see in depth about this object pool design pattern. For now, just get this idea theoretically. Please, we will try to implement these theoretical ideas in the practical way in the upcoming video. Thanks for see about the chain of responsibility design pattern, theoretical real life examples, and then principles. In the next video, we will try to cover the practical implementation of chain of responsibility design pattern. So this comes under this chain of responsibility design pattern comes under behavioral design pattern. There are 3 categories of design patterns. One is creational, structural, and then behavioral. This comes under behavioral design pattern. Here the main motto behind the chain of responsibility design pattern is avoid coupling the sender of a request to its receiver by giving more than one receiver object a chance to handle the request. So here if suppose we assume this is a client and these are some servers, instead of assigning the jobs to a particular server, if we don't assign to a particular server, that request would be solved by any servers at runtime. So for example, if you are using Amazon website, if you are trying to log into the Amazon website using username and password, and then our request would be served by any one of those Amazon servers. So the client won't aware about the server details, etc. The client fire some request, that request would be solved by any of those servers, and then chain the receiving object and pause the request along the chain until an object handles it. For example, we will take the previous example itself. If you are logging to the Amazon website, we are trying to give the username and password. If suppose this receiver 1 will handles only the permission related information. For example, this receiver knows only to check whether that user name and password are valid and etc. Valid only. And after doing that operation, this receiver 1 will acknowledge receiver 2 that I have validated this credentials, then you can take the further jobs like that. And the receiver 2 does some job and then it hands over the remaining job to receiver 3. So chain the receiving objects and pause the request along the chain until an object is handles it. It creates a chain of receiver objects for a request. We have already discussed about this point in the previous example. Each receiver contains reference to another receiver. If one receiver cannot handle the request, then it will pass to the next service. We have already covered about this point in the previous explanation. If a client is sending some request to the server, if one receiver doesn't know how to handle that request, that would be forwarded to the other receiver by using the reference. This receiver 1 will have the reference of receiver 2, this receiver 2 will have the reference of receiver 3. And then these are the two categories by which a chain of responsibility design pattern can be implemented. First category is one receiver handles the request in the chain. Second category is one or more receivers in the chain handles the request. We can explain about these categories using real life examples. So this is the one receiver example, and this is this second example to explain about one or more receivers acting at the same time. For example, we will consider a quiz competition. Lenny is the quiz competitor. Lenny is conducting the quiz competition, and Raja, Chenchu and Sudha are the quiz competitors. They are trying to attend the quiz competition. So first Lenny is asking the question to Raja. If suppose Raja doesn't know the answer for that question, Raja will transfer that question to Chenchu. Chenchu will try to answer that question. If Chenchu doesn't know the answer about that question, then he will forward that question to Sudha. Here the request has been forwarded to other receivers if the receiver has no idea to reply to that request. So this is the example where one receiver handles a request in the chain. Another example is one or more receivers handles a request at the same time. For example, if suppose Lenny is visiting an ATM machine and he is trying to withdraw 520 rupees. If he is entering 520 rupees, that 520 rupees would be handled by 3 receivers at the same time. 100 rupees receiver, 50 rupees receiver, 20 rupees receiver. So what the 100 rupees receiver will do is it will try to pick the best number of number of 100 rupees notes, and then 50 rupees receivers will try to pick the number of 50 notes. 20 rupees receiver will try to pick the number of 20 rupees notes. So for 520 rupees, the 100 rupees receiver would return 4 into 100, which means 400 rupees. 50 rupees receiver would serve 2 into 50, which means 100. 20 rupees receiver would serve 1 into 20, 20 rupees. Here 3 receivers are acting at the same time. So 3 receivers are communicating with them, communicating among them to reply the client with the best response. So that's the second case where one or more receivers are handling a request in a chain. So this is the example about the chain of responsibility design pattern in real life example. If you have any other doubts, you could comment those things in the comment section. I will try to answer those whenever I see it. Now we are going to see about the interpreter design pattern, theory, principles, real life examples. In the next video, we will try to cover the interpreter design pattern Java implementation. So if you want to buy software design patterns book, you could buy the book using the product link which is the description box of this video. So let's come to this point. So interpreter design pattern. So in our real life, in our daily life, we would have been using interpreter at various points of the time. For example, if you are using Google Translator, which is one of the important and best examples for interpreter. If you give in English, if you want to convert that English language to some other language like Telugu, Tamil, that Google Translator will do for us on behalf of us. Here that Google Translator is acting as an interpreter. So it interprets some input to some other output. So this is the first point. It provides way to evaluate grammar or expression. So in our real life, Google Translator has set of grammar. So for example, for English there is a set of rules, for Tamil there is a set of rules, and for all the languages there are set of rules. Using the rules only we will try to talk with others. So similarly, if you are writing any program which contains set of rules or grammars, then we could use interpreter design pattern for that. And then useful for developing domain specific languages or notations. If you are writing a program for one specific domain, if you want to extend that to some other application
without adding any other things, then you could use the interpreter design pattern. So we will try to cover this point using real life using Java implementation in the next video. And then ability to define a language grammar. If you're developing any language like Java, C++, and some other languages, then you could use the interpreter design pattern to design the language in such a manner that could be easily extended, reliable, and scalable. And then Java compiler that interprets Java source code into bytecode. So here in our daily life we would have been using interpreter in Java itself, because Java code is interpreted into bytecode using compiler. This compiler will convert the Java source code to bytecode. Here the compiler is acting as an interpreter which converts the source code to bytecode, and then after converting to bytecode, that could be consumed by n number of JVM machines, so Java virtual machines. So for example, if you are trying to execute bytecode in Windows, Linux, and Mac, the output should be same. If you're executing in Windows, you shouldn't get irrelevant output. All these platforms should get the same output. So that's why Java is called platform independent. Here interpreter is acting at two ends. One is at the compiler end and also one at the JVM. So here interpreter is used to convert interpreter which is in the compiler, which is used to convert Java source code to bytecode, and then interpreter which is in JVM, which is used to execute the bytecode at various platforms. So in our real life itself, we are using interpreter at various points, and then defines a grammatical representation for a language and interpreter to interpret the grammar. So for example, if you are designing a big complex grammar, so in that it involves a number of rules, means then we can use the interpreter design pattern to design those things. And then this interpreter design pattern is widely used in compilers. If you want to build any compiler, your custom made compiler, then you could use interpreter design pattern to design the compiler. Using that interpreter design pattern, you could design a compiler in such a way which can be easily extended. So that's the power of interpreter design pattern. We will try to cover this interpreter design pattern Java program in the next video. So please don't skip the next video. Thanks for watching this video. It's about iterator design pattern theory, principles, real life examples, and real time examples. In the next video, we will try to cover iterator design pattern practical implementation using Java. If you want to buy software design patterns book, you could use the product link which is at the description box of this video. You can just click on that link. You can buy the book online itself. The book price is very cheap. So first we will try to cover the first point. Access the elements of a collection object in a sequential manner without any need to know its underlying implement representation. So we can relate this with the real life example. So for example, this is a container. So there is a container. In this container there are various packages, like there is a food package, and then there is a medicine package, and then there is a toys package, and then there is a what can we say? We can say this about glass, which means delegate materials. So here this is a container. This container is moving from Delhi to Chennai. This container is containing these packages: food package, medicine package, and then toys package, glass package. So this point states that access the elements of a collection object in a sequential manner without knowing to know underlying representation. If this container needs to be delivered to some person in Chennai, we can relate that person. This is that person. This is the person who has bought this container. Here there is an intermediate person. This is the person. This person will try to unload this container packages and he will deliver those packages to this person. This is the owner of this container, and he is the iterator. He is iterator. He will try to access each package and he will try to give that package to the owner. So first what you do is you will try to check whether the container is containing something or not. Yes, it contain initially the container is containing food, toys, medicine and glass. So you will try to access the topmost, which means this point, sequential manner. So first he will try to access the glass. So he will try to access the glass and he will try to deliver that glass to the owner, and then he will try to check whether any other packages are available in container. Yes, food, toys, this package over, food, toys and medicine. He will try to access the next element, which is next package, which is toys, and then he will deliver the toys package to owner. So once again this iterator person will check whether the package is containing any other items or not. Now the package is containing food and medicine. He will try to access the next package called medicine, and then he delivered that medicine to owner, and then he will try to access the food and he will deliver that food package to owner, and then he will check whether the container is containing any other packages. Now the container is empty. So this iterator has done its job. So that's the point here. Access the elements of the collection object in a sequential manner without any need to know its underlying representation. This owner needs to access these packages, but you don't want to know the internal implementation, which means how to handle those packages, what are the ways to handle the packages so that the package won't get damaged. That would be handled by this iterator. So that's his point. And the second point is collection can be list, set, array, it can be anything. For example, suppose if you consider any programming language, you could hear this word called collections. The collection is a group of things like set, list, array and etc. So iterator plays a major role. Suppose if you know somewhat about programming language called Java, then you could have heard about the iterator in collection package. So here the iterator is a class which is used to access the elements in the collection. And then OOPS. In OOPS, iterator pattern is a design pattern in which an iterator is used to traverse a container and access the container's element. So we have already discussed about this point in using this example. And then abstract the details of traversing the collection. So here this owner don't want to know the implementation details of this package information, so that would be handled by the iterator. That's what this point is stating. Abstract the details of traversing collection. So here the owner has abstracted this iterator handles those difficulties. This owner don't want to know about those difficulties at all. So this is about the iterator design pattern theory, principles, real life examples and real time example. In the next video we will try to cover the iterator design pattern practical implementation using Java. Thanks for watching. Discuss about mediator design pattern theory, principles, real life examples and real time examples. In the next video we will try to discuss about mediator design pattern practical implementation using Java. So first, what's a mediator design pattern? Mediator design pattern is one of the important design patterns which falls in the behavioral design pattern. So basically there are three categories of design patterns. First one is creational, next one is structural, third one is behavioral. So mediator design pattern falls under behavioral design pattern. So before discussing about mediator design pattern, we will try to discuss about the real life example so that you could get the theory behind mediator design pattern in a better manner. So let's consider an airport. So this is Chennai airport. In Chennai airport, if you have so in Chennai airport, a number of flights would be landing at some time, on timely basis. For example, for every 5 minutes a flight would be landed. So similarly, a flight would be take off from that pathway for every 5 minutes. So here this is the busiest airport in India, one of these busiest airport in India. If suppose, let's consider a situation where 3 flights are trying to land at the same time. So A, B, C. So A is one plane, B is one plane, and C is one plane. If suppose these 3 planes are trying to land on a particular pathway at a particular time, if there are no intermediates between them, if these 3 planes don't communicate well, then the situation will be in a very
bad manner. So if suppose if these three flights are trying to land on a particular pathway, then there would be many chances that the flight would be dashed together and it could be busted. So to overcome this situation, every airport has ATC. ATC means air traffic controller. So what they would do is they will try to communicate with the every plane that is trying to land on a particular pathway, and they will try to communicate between multiple planes. So here, if suppose A, B, C are trying to land on a particular pathway, ATC will intimate A that A, B, C that three planes are trying to land on that pathway, so please try to be safe. And then ATC will guide the planes which one needs to be landed first, and then next, and then other, and then the third one. So here ATC is playing a major role. So air traffic controller is playing a major role. If suppose if A needs to communicate with C, there won't be any communication facilities at all. So if suppose if A needs to communicate with C, what A would do is A would try to communicate with the ATC, and then ATC would get the information from C, and ATC would give that information back to the A. So here ATC is playing another role. So it's acting as a mediator. Suppose if A wants to get some information from C, means A will try to intimate that information to ATC. ATC will get that information from C, and then ATC will give back that information to A. So here ATC is playing another role called mediator job. So it's trying to interconnect all the planes and trying to get the information and trying to give back that information to the required plane. So this is the real life example where mediator design pattern is playing a major role. Here ATC is a mediator. So we can consider another example. Now we are trying to consider an example where multiple objects are trying to communicate with each other. So A, B, and C. A, B, and C, and D. So these are the four objects that are trying to communicate with each other. If there are no intermediate means, then what if suppose A needs to communicate with B, C, D, means there should be some connection between A to B, A to C, and A to D. And then if suppose B want to communicate with A, means then there should be some connection between B to A, B to C, and then B to D. Similarly for D. So for D, if suppose D wants to communicate with A, means there should be connection between D to A, D to B, and then D to C. So here it's a complex communication. To overcome this, the mediator design pattern, to overcome this hurdle, mediator design pattern is playing a major role. A, B, C, D. These are the four objects. If suppose A needs to communicate with the other object, instead of communicating with the other object directly, it will communicate with the mediator object. So if suppose A wants to communicate with B, C, D, it just communicate with M, and it will try to give the required information. That mediator object will do the remaining job. Similarly B, C, D. So if you look at this picture, you could see the complexity behind the scheme. If you look at this picture, you could see the simplicity behind the scheme. So if A needs to communicate with the B, C, D, it just communicates with the M, which means mediator object. So mediator object will handle those hurdles and other things behind the stuff. So now we'll go back to the slide. We'll try to discuss each point in a detailed manner using these examples. The first point is reduce the communication complexity between multiple objects. So this is the scenario where multiple objects are trying to communicate with each other. If there are no mediator objects, then the situation would be very bad. Since there's a mediator object, the communication between multiple objects becomes simple. And the second point is pattern provides a mediator object which handles all communication difficulties between objects. So we can relate that point with this example. So once again, pattern provides a mediator object which handles all the communication difficulties between the object. Suppose flight A is trying to communicate with flight C and flight B. Since they are flying in the sky, they don't have they won't get a chance to communicate with each other because of some radio frequency problems like that. Here If A needs to communicate with C flight and B flight, it just communicates with the ATC, air traffic controller. That air traffic controller would communicate with the C flight and B flight and get the required information, and then it will give that information to A. And then Mediator is the communication center for the objects. We have already discussed about this point while explaining the examples. And then an object needs to communicate with the other object. It doesn't call the other object directly. Instead, it calls a mediator object which handles those headers. So this is the example. If suppose A needs to communicate with B, C, D object, it won't communicate. It won't communicate with the subject directly. Instead, it communicates with the mediator object. Mediator object will take those difficulties and then reduce the coupling between the objects. So here it's a tightly coupled. Here it's a loosely coupled. That tightly coupled means if A needs to communicate with B, C, D, A needs to have the references of the B object, C object, and D object, which is a tightly coupled, which is a tightly coupling example. Whereas if suppose A needs to communicate with B, C, D, it needs to have just a reference of mediator object, so which is loosely coupling. So these are the theory, principles, real life examples, and real time examples of mediator design pattern. In the next video, we will try to cover the practical implementation of mediator design pattern. So thanks for watching.
We are going to discuss about null object design pattern theory, principles, real life examples, and real time examples. In the upcoming video, we will try to discuss about null object design pattern practical implementation using Java. So what is null object design pattern? So traditionally, which means if you are a programmer, you would know that you would use null check for everything. For example, if you are writing a program for adding two numbers for A plus B. So what you would do is you would first check whether A is not equal to null and then B is not equal to null. So here we are trying to check whether both values are not equal to null. Then only we will proceed to add these two numbers. So here A not equal to null and B not equal to null are null checks. So that is a traditional method. Null check for every value which has some limitations and declared for. If you have failed to put the null check, then that would cause some exceptions. For example, A equal to null, so B equal to some 5. So null plus 5 will throw null pointer exception. So if you want some default behavior for objects which has null for nothing, so if you want some default behavior, then we could use null object design pattern for achieving this same. So we will try to discuss an example so where we could explain the null object design pattern in a detailed manner. So please stay tuned to this video. And then next point is null object class is a default implementation. Default implementation means whenever your program requires some default implementation for nothing and null values, then you could use null object design pattern. So last point is it would be very useful if you want some special flow for something which has nothing and null value. So we can explain that point using some real life example. So for example, these are the people from whom you get the call every day. For example, A, B, C, D and E. These are the people who always call you, and the call between you and them are very important. So you are considering them as important persons in your life. And then F, G, H, I. These are the spammers. So they will try to call and they will try to tell that you have won 50,000 rupees. So please provide your bank details. So we will credit you some amount. So for those people, you will treat them as spammers. You need to reply them only one default message, which means I am not interested. So here F, G, H are null, which means nothing. They are nothing to you. So you need to just reply them with just one message, which is I am not interested. So here we can consider this your, and A, B, C, D are important persons for you. So you will try to call, if these people call you, then you will try to talk with them in detailed manner and you will try to discuss many things. If F, G, H, I people call you, then you could reply only one thing, which means I am not interested. So here I am not interested is the default message, which could be handled using null object design pattern. So we will try to cover this example practically, which means we will try to implement this using Java in the next video. So please stay tuned to this series. Now we are going to discuss about observer design pattern theory, principles, real life examples and real time examples. In the next video we will try to cover observer design pattern practical implementation using Java. So before discussing about observer design pattern, I will try to convey some information regarding a software design patterns book. So many people ask me regarding the software design patterns book, which is the best book, and where can I buy that, like that. So the best book information would be provided at the description box of this video. You can click on that link for buying the book on online itself. So let's dive into the software design pattern. One of the important design patterns under software design pattern is observer design pattern. So first we will try to cover a real-time example where observer design pattern is playing a major role. So suppose if you are trying to buy a smart TV on online, so this is a smart TV. So nowadays many people are buying the electrical gadgets on online. So this is one of the gadgets that people are willing to buy. So because of huge demand, the product availability has become less. So the online shopping sites are trying to follow another strategy called flash sale. So they are trying to sell the most demanded products on flash sale. So flash sale means, so the flash sale will last only for 2 to 3 seconds. So if you are lucky, you could buy this product at that time. So the flash sale would be available on every week or on every month, on monthly or weekly basis. If suppose if 4 people are willing to buy this product, so this is one, second one, third and fourth one. These 4 people are trying to buy this product, but for the first time they have failed to buy this product because of stock unavailability. So what they are trying to do is they are trying to register with this product on that online site. So whenever this product is available, then the notification would be sent to these people. So this subject will send the notification to the registered people. So here we can relate the smart TV as a subject and these people as observers. So these people are observing something. These people are trying to buy the product. So they have registered with this subject. Whenever the product is available, that notification will be sent to these observers. So these are the observers. We are trying to buy some product and we are trying to register with them. So here, first observer, second observer, third observer, fourth observer. The first observer doesn't know the information about the second observer. Second observer doesn't know the information about the third observer. But all the information would be available for subject. So A, B, C, D. So these A, B, C, D are the observers. A, B, C, D. Subject would hold the observer IDs, which means A ID, B ID, C ID, D ID. Subject won't hold all the information about all the observers. So subject won't hold the observer name, observer details, observer city, observer previous purchase details, like that. Subject would hold only the observer IDs. So this is the example where observer design pattern is playing a major role in real life scenarios. We will try to relate these points with the example. So first one is behavioral design pattern. Behavioral design pattern, this observer design pattern falls under behavioral design pattern. The reason behind that is it behaves based on some state. And then second point is object or subject maintains all its dependents called observers. So here this is a subject or object which maintains all the information about not all the information, which holds information about all the observers. Here it holds only the information about the observers as observer IDs. So it holds the observer A ID, observer B ID, observer C ID and observer D ID. It won't hold the observer A personal information like name and the other stuff. it holds just a ID for communication. And then one-to-many dependency between objects. One object changes state and all its dependents are notified and updated automatically. So this is the subject. If suppose this subject is changed from unavailability to availability state, then all the observers, which means all the objects which are registered to this subject, would be notified. That is this point. One-to-many dependency between objects. One object changes state and all these dependents are notified and updated automatically. And another point is subject or publisher doesn't need to know anything about the observers or listeners. So I have already talked about that point in the while explaining the example. Subject doesn't maintain all the information about all the observers. Like it won't maintain the observer A personal data like name, age, date of birth, and other stuff. Subject would hold only the observer A ID. That's it. And then very loose coupling. Here A, B, C, D are observers. They are linked with the subject. So here one-to-many dependency. Subject one and observers are many. So it's a very loose coupling. And then limitation. So subject or publisher may send updates that don't make sense to the observers. For example, if these are the 4 observers, if A observer has already bought this product on another online site, since A has registered with this subject on another site, this site would send the notification regarding this product availability on weekly or monthly basis. Those notifications are irrelevant to this observer. So this is one of these limitations, but this limitation can be overcome by using some other methods. So we will try to cover those things in the upcoming videos. So subject may send updates that don't make sense to the observers. So thanks for watching this video. Discuss about state design pattern theory, principles, real life examples and real time example. In the next video we will try to cover state design pattern practical implementation using Java. So first let us explain with this state design pattern using real life and real time examples. So let's consider an ATM machine. If you are if you are trying to withdraw some amount from ATM machine, what you need to do is you need to insert your card and then you need to enter your PIN and then you need to enter the amount that you need to withdraw, and then that machine will give back the required amount based on if all the criteria satisfies. Here we can consider 2 states. First state is card is not inserted into the into the ATM machine. Second state is card inserted into the ATM machine. Yeah, these are the 2 internal state. If you are in the first state, if you haven't inserted your card into the ATM machine, then you could see only the advertisement and the promo videos on ATM display screen. If you have inserted your card into ATM machine, then that ATM machine would ask you the PIN number. If you have entered your correct PIN number, then you could do these following tasks. Example, you could withdraw some amount, or you can check the balance, or you can do other stuff on that. So here these two situations are considered as an internal state: card not inserted and then card inserted. So these are the 2 states. Based on state, the behavior is completely changed. So for example, this is the example why the state design pattern falls under behavioral design pattern. So yeah, based on state, the behavior has been completely changed. So this is one of the real life examples, and then this is another real life example. If we are considering a human life, we are also falling under state design pattern. If this human is IT professional, so he always does some work, he always does some behavior based on time. So for example, on every day 8:30 he will travel to office. So this is one of the states. And then second state is 9:30. So 9:30 AM he will try to have breakfast. And then another state is 10 AM to 1 PM. This is another state. So here at that state he will try to work in office. So these are the 3 states where the human life is completely, human life or behavior is completely changing based on the internal state. At 8:30 was traveling to office, at 9:30 he is trying to have breakfast, at 10 to 1 p.m. he is trying to work. So these are the examples of state design pattern. We will try to cover these points with these examples. So first point is behavioral design pattern. State design pattern falls under behavioral design pattern. The reason behind that is based on state the behavior is completely changing. So here card not inserted, so you can't do anything, you can just view the promo videos on ATM display machine. If you have inserted a card and then if you have given your correct pin number, then you could do withdraw option, and you could use withdraw, check balance and other features also. So based on internal state the behavior is completely changing, and then allows an object to alter its behavior when its internal state changes. So I have already discussed about this point in the while explaining this example. So this is about the state design pattern. So this is one of the important design patterns which falls under behavioral design pattern. We will try to cover a Java implementation for this state design pattern in the upcoming video, so please stay tuned. Thanks once again. About template design pattern, template method design pattern, theory, principles, real life examples and real time examples. In the upcoming video we will try to cover template method design pattern, practical implementation using Java. So let's come to this template design pattern. So before that I will try to clear this screen so that I could explain from scratch. So it defines a sequence of steps of an algorithm. So for example, if you consider any algorithm, there could be n number of steps. You need to follow those steps in a sequential manner. So only if you follow those steps in a sequential manner, then you could you can execute the algorithm with the correct output. So here we are trying to consider an example where we could use that example for explaining the template design pattern. So let's consider an scenario. So if you want to consider a house, so you need to follow these steps. For example, first you need to construct the basement, and then what you need to do is you need to construct the pillars, and then what you need to do is you need to construct the side walls, and then what you need to do is you need to do the interior design. So these are the 4 basic steps that you need to follow for constructing an house. So it can be cement house, it can be wooden house, it can be any house, but you need to follow these steps. So let us consider the second, let us check the second point. Subclasses can override the steps, but it won't allow to alter the sequence of steps. So for example, if suppose there are 2 subclasses, for example, cement house is the one subclass, cement house is one subclass, and wooden house is another subclass. So if suppose if these 2 houses need to build some house, if you need to build cement house and as well as a wooden house, you need to follow the same thing. You need to follow the same sequence. First you need to build the basement. If suppose if there is cement house means you need to build the cement basement. If suppose if the house is wooden house means you need to build the wooden basement, and then you need to fix the pillars. If suppose if it's a cement house means you need to use the cement pillars. If suppose if it's a wooden house means you need to use the wooden pillars. So here the point is the sequence of steps remains the same, but the actual implementation may differ, but sequence needs to be followed. So this is one of the examples where template method design pattern is widely used, and another example is software development process. For example, let us consider softwares. A and B are 2 softwares. A software mainly focuses on military security information management. B software focuses on medical information management. So it can be any software, but it need to follow this sequence. For example, first you need to analyze the software requirements, and then what you need to do is you need to design the software. You need to design the class diagrams, you need to design this flow, and then etc. And then you need to develop, and then finally you need to test. So it can be military software, it can be medical software, it can be educational software, it can be any software. It needs to follow these steps. So these are the examples where template method design pattern are widely used in real life scenarios. So in the next video we will try to discuss template design pattern using Java implementation by taking some use case. So thanks for watching. So please stay tuned
To discuss about visitor design pattern, real life examples, real time examples, principles, and the use cases where we need to use visitor design pattern. In the next video, we will try to cover the practical implementation of visitor design pattern using Java language. So please stay tuned to this series. Before discussing about the principles, what we can do is we will try to explain this visitor design pattern using some real life example. So further, I am taking a shopping mall example. So this is a shopping mall. Let us consider this a shopping mall. So in shopping mall, we can buy many kinds of products. For example, we can buy food products, we can buy toys, we can buy dress, we can buy food utensils. So these are the four categories of products that we can buy in shopping mall. So let us consider a scenario where a country changes the tax percentage for each category on every month. So let us consider 3 months: Jan, Feb, and March. So these are the 3 months that we are considering. So that country changes the tax percentage on each month. So for each month, for example, if that country decides 5% tax for food products for Jan month, and 10% for toys, and 15% for dress, and 10% for utensils. For February month, the tax percentage varies. So the government decides that the tax percentage for food is 10% for February month, 5% for toys, 15% for dress, and 15% for utensils. For February March month, once again it varies: 5%, 10%, 20%, and then 30%. So here for each month the tax is getting varied. So here we can consider this food, toys, dress, and utensils are elements. So we can consider these things as elements, and we can consider 3 objects: Jan, visitor; Feb, visitor; March, visitor. So here for each month the tax is getting varied. So based on element, for example, food, toys, dress, utensils are the elements. For food, the tax percentage for Jan month is 55%. So that could be handled by the visitors. So these are the 3 visitors who are visiting the products or elements, and they are determining or executing some algorithm. So if Jan visitor visits the food, toys, dress, utensils elements, then it determines the tax percentage for that month. And then the next visitor comes for the next month, which means February month. The February visitor is visiting food, toys, dress, and utensils, and it is determining the tax percentage. And then March visitor is visiting the elements: food, toys, dress, and utensils, and then it is determining the tax percentage for that month. So here this visitor is playing a major role. This visitor is determining the tax percentage for the elements based on various criteria. So that's these points. It changes the execution algorithm for an element object. So these are the elements: food, toys, dress, utensils. The execution algorithm varies as the visitor varies. So execution logic varies as the visitor varies. Here, if Jan visitor visits food products, then it determines the tax as 5%. If February visitor visits the food product, then it determines the tax percentage as 10%. That's the second point explanation. And the third point states that element object has to accept the visitor object so that the visitor object handles the operation on the element object. So here, these are the 4 elements. These 4 elements need to accept the visitor objects so that the visitor object can execute its algorithm on the elements. So this is the simplest example where the visitor design pattern is playing a major role in real life example, in real time.
So we can consider another scenario where visitor design pattern is playing a major role in our real life. For example, if we are conducting 3 types of functions like marriage and then birthday function and then wedding anniversary. So you are inviting your friends and relatives for these 3 functions. So here the relatives and friends are the visitors. They will buy gifts for your function based on the function type. If the function is birthday function, then they will try to buy toys and chocolates like that. If the function is wedding anniversary, they will try to buy some jewelry or some bouquet like that. So here the visitors are determining visitors are trying to buy gifts based on the function type. So here visitors are trying to generate the tax percentage based on month and product category. So this is the example where visitor design pattern playing a major role. We will try to cover a Java implementation of a real life use case to cover the visitor design pattern in the next video. So please stay tuned.
Now we are going to discuss about adaptive design pattern in theoretical using some real life examples and real time technical examples. In the next video, we will try to cover how to write a simple program for implementing adaptive design pattern using Java. So first, what is adaptive design pattern? So if you think about adapter, you would have come across this name in your life many times. So you would have intentionally known about this, or sometimes you have unintentionally you would have used the adapter for solving your real-time problems. So we'll try to cover those problems using real-life examples. So the definition between it falls under structural design pattern. So there are 3 types of design pattern. It falls under structural design pattern. You would get the idea why it falls under structural design pattern when we actually implement a simple program for adaptive design pattern. So that would be covered in the next video. Please try to watch that video also. It acts as bridge between 2 incompatible interfaces. So for example, we will try to cover this using real life examples. Suppose if you are using MacBook Pro means, so what you would have observed is there won't be any USB ports at all. So there would be only USB-C port. So this is the USB-C port and these are USB port. If you want to connect this USB port to our MacBook Pro means, what you need to do is you need to buy this adapter. This will convert this USB to USB-C. So what we need to do, we need to just insert this in the adapter port and it will convert this USB to USB-C. So this is one of the important examples. And the next example is memory card reader. If you are using any laptop or PC means, at most of the laptops and PC, there won't be any memory card reader inbuilt. So what you do is you will try to get a memory card reader for that and you will try to insert your memory card in that and you will try to connect in the USB port. So this is one of the adapters. And then is the phone adapter. If you are trying to charge your phone means, what you do is you will try to insert the pin into a phone and you will try to put the adapter in this socket. That adapter, what it do is it will try to convert the 220 to 220 volts. So basically in India 220 volt is the power that we are getting for household purposes. So it will convert the 220 volt to 9 volt for phone applications, for phone usage. So this is the real life example. These are the real life examples. We will try to cover the technical real time examples. If you are using, suppose you are writing any Java application and that Java application needs to connect with the database means, for the people you write in Java base, they don't aware about the database that is behind. For example, it can be Oracle or it can be MySQL or it can be Sysbase. Based on time, the database may convert to the advanced databases. For example, so if a new vendor is providing a better database means, the people behind that will change that that actual database thing. So we don't aware about the database behind running. You just need to write an application using some command, some statements, some MySQL, some SQL statements. That adapter class would handle those problems, that will handle those things. For example, if you are trying to migrate from Oracle to Syspace, means that adapter class will be changed. So this should be handled by this adapter class. So this is the real-time technical example. We'll try to cover the implementation in the.
This is our case. Now we are going to see what is bridge design pattern in a detailed manner using real life example and real time examples. In the next video, we will try to write a Java implementation for bridge design pattern. So in this video, we will talk about the theoretical content about bridge design pattern using some examples. So first, what is a bridge design pattern? Before going to discuss about bridge design pattern, we will see what is a bridge. Generally, the bridge is used to overcome some hurdles without knowing the internal implementation. For example, if suppose consider this is a lake and this is a bridge. If you want to cross this lake, you can use this bridge and you can cross this bridge. You don't want to know the architecture or the raw materials that are used for constructing this bridge and etc. So you just need the bridge to cross this lake. You don't want the internal architecture and the other stuff for crossing the bridge. So here this is called abstraction. So we are ignoring the internal architecture or inner details about the implementation. So similarly, if you take any software, there would be two layers. One is abstraction and then implementation. So what is abstraction? Generally, if you develop any software, if you are using any APIs, for example, if you are using Java APIs, consider the map sort example. If you are using map, or if you are using any of those collections like map, array list, and then linked list, etc., you don't want to know the inner implementation details about that. You can just call the methods like .add, .add all, .put all, etc. So the inner implementation would be taken care by the Java community. Similarly, here that is called abstraction. You don't want to know about the inner working details for using those APIs. In real life example, we can consider a fan example. If you want to run the fan, you can just switch on the fan. You don't want to know the inner technical details about the fan. For example, what are the raw materials used for what are the coil which is used in the fan, and then what is motor condition, like that. You just want to run the fan, you can just put on the fan, you can just put on the switch of the fan, it will run. So here it is called abstraction. So this bridge design pattern comes under structural design pattern. So structural design pattern is one of the important 3 categories of design patterns. This is called structural design pattern. So here the main concept and main motto of the bridge design pattern is to allow the abstraction and implementation to act independently. So the abstraction layer can be written independently without knowing the implementation details. Similarly, the implementation can be written without knowing the abstraction details. So both can be independent. So for example, let's consider an example. So if you are a software developer and if you are using some software APIs for writing an object. For example, you are writing an object, save object. You are just calling that object. You are just calling that method called save object. This is called API. You are calling this API. So here this API, initially they have used a file to store the data, and then after 2 years what they did was they have upgraded this file mechanism to database mechanism. So they have used MySQL or some PGSQL database for storing the objects. Here these details would be abstracted to the client. So if the client can just call save object, the inner technical details can be handled by those implementing classes or implementing APIs. Here you can throw any implementation at any time without affecting the abstraction layer. So client don't want to worry about those things. If suppose if after 2 years, if a new technology comes, then that implementation can be upgraded to new implementation. So here database can be replaced with some other new technology. So here the client need not to be worried about those things. You can just call save object. The inner things can be handled by those implementing classes. And then if suppose if the client is asking about get object, similarly what would if suppose that the object was stored in file, then the object would be retrieved from file. If suppose if the object was stored in database, then from the database that object would be retrieved. So the client need not worried about the inner mechanism. You can just call those API methods. You can just abstract this client as the abstraction over the implementation. This is one of the important examples where bridge design pattern is playing a major role. And then consider another example. We will consider a real life example. If suppose if you are a retail shop owner, if suppose what you do is you would send message to the customers, to the regular customers regarding the new products whichever whenever it comes to a retail shop. So you need to intimate the customers via SMS, or email, or Facebook Messenger, or Twitter. The only way is you don't have any technical knowledge regarding that. So what you do is you have bought some software for doing that. You could just click on send message. Here the inner technical details are abstracted from the implementation that would handle all the technical details. For example, if suppose if the end customer uses mobile, then when you click on send message, then the SMS would be sent to the client. If suppose if the end customer uses email means, then this triggering button would send the email to the end client. If suppose if the end customer uses FB means, then we are using messenger, this end message would be sent. So here the technical information would be hidden for the client. So the client can just call some method to use those technical information. So here the technical details are abstracted for the client. So these are some real life examples where bridge design pattern is playing a major role. We will try to implement some sample code using bridge design pattern in the next video. So please stay tuned. I want to discuss about composite design pattern, real life example, real time examples, definition, and then in the next video we will try to implement a sample program using composite design pattern. So for now we will just try to cover the theoretical information about composite design pattern and using real life and real time example. So before that, this composite design pattern falls under structural design pattern, so which is one of the important interview point of questions. So this falls under structural design pattern. And then composite design pattern, the main category, the main motto of composite design pattern is if our object can be represented in 3 structure, then it can be considered as composite design pattern. So you need to represent the object in 3 structure, So for example, we can consider some diagram like this. So this is your object, this is your complex object. If your object can be represented in 3 structure, then you can consider it as a composite design pattern. And then the second rule is the nodes are classified, and the second principle is the nodes are classified into 2 types. One is composite and then another category is leaf. So this is called composite and this is called leaf. We will try to explain those things using some real life example. If suppose if you are buying any car, then the car would have engine and then the car would have tire. For that engine, it could have made up of some electrical components, and then that engine would have some valves, and then that electrical components would have some electrical chips, and then the electrical component would have some transistors, and then this is some tree structure of some complex object called car. Here, if suppose if some operation can be applied on a leaf object, then that operation should be applied on other composite and other leaf objects also. So first, before going to that, first we'll try to classify the composite and leaf objects in this complex object. A composite object would be car, engine, electrical components are the composite object. The reason behind that is a composite object is an object which contains which would be having some child objects. Here car is having engine and tire as a child objects, and then engine is having electrical component and valves as child objects, whereas tire, valves, transistors, chips are not having any child object. So these would be considered as the leaf objects. So any object which is containing some child objects would be considered as composite object, and objects which don't have any child object would be considered as leaf objects. So here tire, valves, transistor, chips are the leaf object. If suppose if you perform some operation on the child objects, for example get price is the operation, which is a method which can be applied on transistor object, chips objects, valves, tires. Here this create the price operation are being applied on all the leaf objects, then that operation should also apply on the composite objects called car, engine and electrical component. So you can get the price of transistor, get the price of the chips, get the price of valves, get the price of the tires, engines, electrical components, cars and etc. So here the operation which is applying on leaf object is also applying on the composite object and other leaves and other composite object. Then this would be considered as a composite design pattern. So these are the two principles and rules that are needed for qualifying the tree structure of an object into composite design pattern. There are various criteria, there are various use cases where we would use composite design pattern in real life examples to solve real life problems. We will try to cover one of those real life problems using Java implementation in the upcoming videos. So please stay tuned to this channel. Now we are going to discuss about the decorator design pattern in a theoretical manner using real life example and real time example. In the next video we will try to cover the sample program to explain decorator design pattern in a detailed manner. So first, what is a decorator design pattern? So this decorator design pattern falls under structural design pattern. So structural design pattern, and then this decorator design pattern is used whenever an object needs to behave dynamically at runtime based on the request, then we can use decorator design pattern. So for example, this is a definition: additional responsibilities for an object at runtime. So we are adding additional responsibility for an object at the runtime without affecting the base object. That's important, without affecting the base objects. That's the important point. So we will try to explain about this using some real life example. So for example, if you are going to some supermarket and if you are buying some cone, what you do is you would ask the customer, you would ask the food server to serve the ice cream based on your request. So this is a base ice cream or base cone. If one of the customers is asking I need some vanilla ice cream, so what that food vendor would do is he will try to use that base, and then he will try to fill the vanilla ice cream. So here this is a base object. This base object is converted to custom object based on user request. So here the base object is added with some additional responsibilities. Here vanilla ice cream is the additional responsibility at the runtime. So this is one of those examples. Suppose another customer is coming, another customer is asking about, he is asking that he needs the chocolate ice cream. So here the vendor is filling the chocolate at the runtime. Here chocolate is the additional responsibility added to the base object at the runtime. So this is the another scenario in a real life. So we will try to cover another example. If suppose this is the plain pizza, and if a customer is coming to the pizza shop and the customer is ordering, I need some chicken pizza. Here the food chef, what he would do is he would take the base object, which is a plain pizza, and he will add some extra responsibilities, in our case which is chicken, at the runtime dynamically. That's important, that's the more important when it comes to decorator design pattern. So decorator design pattern, when should we use a decorator design pattern? So whenever an object should be treated dynamically at the runtime based on some criteria, then we can choose the decorator design pattern. So we will try to cover decorator design pattern Java implementation in the next video. Please try to watch that video also for better understanding. So thanks for watching this video about facade design pattern in theoretical manner using real life and real time example. In the next video we will try to write a sample program to implement the facade design pattern. So first, what is a facade? In French, a facade meaning is frontage. So whatever you see is called facade. So the main motto behind the facade design pattern is simple interface to a complex system. So the system can be complex, but you need a simple interface to operate the operations. So another principle is single class represents entire subsystem. So your system can contain n number of subsystems, but the end user should see as a single thing. So the entire complexity should be handled by the inner implementation. You don't need to worry about that. So this is the main motto behind the facade design pattern. We can explain that using some real life examples. The first real life example is, if you are using ATM, if you are trying to withdraw some amount from ATM, for example 10,000 rupees. So what you do is you would insert your ATM, you would insert your bank debit card into the ATM, and you would give the required password, which means passcode. So here, once you do that, once you trigger 10,000 rupees withdraw button, then these are the following things that would happen behind the screen. So first it will check whether the account is valid or not, and then it will check whether your account has some sufficient funds for withdrawing 10,000 rupees, and then it will check whether your account, your PIN code is correct or not. So after validating all these things, then 10,000 rupees would be withdrawn from ATM. So these are the complex things that are handled behind the screen. For the user, for the end user, the interface is very simple. You can just click on some button and you can just give the amount that you need to withdraw. The interface is very simple. So this falls in the facade design pattern. So simple interface to a complex system. So another example is, suppose if you are trying to build a building. So for example, that building consists of 10 floors, and each floor should contain some 2 or 3 rooms like that. And then for the quality purpose, you would need to select the better bricks, cement, and etc. Here you would to build this building, you need to maintain many things, and that's a very complex process. So what you are trying to do is, you are trying to give this contract to the building contractor, so who would manage these things in a better manner. So what you do is, you are trying to give 50 lakh rupees to the base building contractor, and you are explaining your use cases to this building contractor. Then this building contractor would handle these complex things behind the screen. The end user don't need to worry about this. This building contractor will worry and manage these things. So here, this is another real life example where facade design patterns is applied. So here, this is the end user need not worry about the complex things behind the screen for building this building. Everything would be managed by this building contractor. So this is another example where facade design pattern is applied. So in the next video, we will try to explain facade design pattern using some sample implementation using Java. So thanks for watching this video.
Now we are going to discuss about flyweight design pattern theory, principles, and real life examples. In the next video, we will try to cover the flyweight design pattern practical implementation using Java. So first, the definition for flyweight design pattern is it is used to create a large number of objects of almost similar nature. For example, if you are going to if you need some thousand copies of some data, the data is in our system. So what we would do is there are two options. So first option is we will try to get the printouts for 1,000 times. So we will get the expected output, which means 1,000 copies of actual data. The other way is we can get printout of one copy and then we can use that copy for taking the Xerox copies for other remaining 999 copies. So by doing the second way, we can save some amount of money. For example, if the shopkeeper is trying to demand 1 or 2 rupees for a copy for printout, then 1,000 into 2 rupees, then the total amount that we need to pay to the shop owner is 2,000 rupees. If we take one printout and then if we ask the shopkeeper to do the Xerox copies of for remaining quantity, which means 9,999, then we could save nearly 1,500 rupees. So in software angle, in software applications also, we can reuse something. If we can reuse something, then we can save memory. So by saving memory, it eventually it improves the performance. So flyweight design pattern is one of those which saves some amount of memory by reusing the existing objects. So it is used to create large number of objects of almost similar nature. If the objects are in similar nature, then we can create n number of objects without expanding the memory, without bombarding the memory. We can reuse the objects. The second definition is large number of objects consumes large amount of memory. The second point is, so there is no large number of objects requires large number. If one object requires 1 MB, if we require 1,000 objects of the similar kind, then 1,000 into 1, we need 1,000 MB memory. Flyweight design pattern provides a solution for reducing the load on memory by sharing objects. The main principle behind flyweight design pattern is share the object which can be shared. It is used to reduce the number of objects created and improve performance. So if you reduce the number of objects that are getting created, then we can eventually improve the performance. That is directly proportional. Reduce the number of objects, then improve the performance. So if you want the better performance, then you need to reduce the number of objects. And the fifth point is it reuses the already existing similar kind of objects and create new object when no object is found. So we can relate this point with the real life examples using Angry Birds so that you could get the information in a better manner. So for example, we would have played Angry Bird game at many times. So for example, we consider this one of the Angry Bird. This is the base Angry Bird, which has 2 eyes, 1 nose and 2 legs. These are the features of this Angry Bird. If we can reuse this object, if we need thousands of similar objects, then we can reuse this object. If we require a similar kind of object, for example, we need this object but of red color, then what we can do is we can use this object from the cache and then we can apply the red color on the fly. So this is the power of flyweight design pattern. So we can create n number of objects of this similar kind without expanding the memory at the runtime. So here we are reusing the object, but we are applying the additional features on the fly. So that's the point. It reuses the already existing similar kind of objects and create new object when no object is found. If a new Angry Bird of different dimensions is required at the runtime, for example, if a new Angry Bird with 2 eyes, 1 nose and 1 leg, 2 eyes, 1 nose and 1 leg, this is the requirement at the runtime. We don't have any objects of this kind. So what this pattern suggests is try to create a new object if it doesn't exist at the cache. So what it will do is it will try to check whether this object is already present or not. If it's present, it will try to reuse that object. If it doesn't present, it will try to create the new object at the runtime, and it will try to reuse for the next successive request. So this is the response. It reuses the already existing similar kind of objects and create new object when no object matches found. And then intrinsic states are constants and stored in memory, and then extrinsic states are not constants and needs to be calculated, and that are not stored in memory. So here intrinsic states are those things which can be saved in memory. For example, this is the one Angry Bird object and this is another Angry Bird object. Here 2 eyes, 1 nose, 2 legs are the constants that can be saved in memory. Here 2 eyes, 1 nose, 1 leg are constants that can be stored in memory. At the runtime, if we need 2 eyes, 1 nose, 2 legs Angry Bird with red color, here red color is extrinsic states. If we need 2 eyes, 1 nose, 2 legs Angry Bird with the blue color, here blue color is extrinsic state that can't be stored in memory, because that are added at the runtime that would be used for that request only, so that need not be stored in memory. These are the some points about the flyweight design pattern. We will try to write a Java program for this in the upcoming video, so please stay tuned to this video. If you want to learn software design patterns in a detailed manner, then you can download the book. That book link would be present at the description box of this video.
See about the proxy design pattern theory, principles and real life examples. In the next video, we will try to cover the proxy design pattern practical implementation using Java. So first, what is a proxy? A proxy means in place of or representing or big of. So this is the general meaning of proxy. So please try to watch this video completely so that you could get the proxy design pattern in a detailed manner, because I have included the real life example of proxy design pattern. So this is the real life example. This is the illustration of the real life example of proxy design pattern. So please try to watch the video completely before please don't skip this video. And then placeholder for another object to control the access. For example, there are two objects. So this is a real object. So this real object, the placeholder for another object to control the object. This is the real object. To access this real object, there is some another object. This is a proxy object. It will try to control the access. If suppose a client is trying to access this real object, this proxy object will come into act, and it will try to check whether client has its permission, and client can and other various, based on various criteria, this proxy object will try to reply to the client whether that client has the access to this real object or not. And then the third principle, proxy is the object that is being called by client to access the real object behind the screen. So this is a client. This client knows only this proxy object. The client doesn't aware about this real object. This proxy object will try to manage the internal things, and this proxy object will try to contact this real object, and it will try to get the relevant information and data, and this proxy object will be served to the client. So this is this is the third point. And then proxy pattern represents the functionality of another class. So this is the real class object. The functionalities of this class object, the functionalities of the main object is replicated by this proxy object. Virtual. There are three types of proxies that are widely used in industry. The first one is virtual proxy, is a placeholder for expensive to create object. For example, and then the real object is only created when a client requests to access the object. For example, suppose if a client is trying to access the student data of a particular student, for example, the client is accessing the student ID 1 data. Here the student doesn't aware about the real object at all. It will see that there is some object. This is a proxy object. The client knows that there are some object that will be served for the request. The client will know the real object won't be created until the client requests the actual thing. Until the client requests. Till that time, this proxy would be shown to the client. When a client actually requests that when the client actually requests, then only the real object would be created. For example, student ID 1 is the actual request. During the runtime on the fly, the student ID 1 data would be fetched from database, and the actual data would be converted to the real object. That real object would be served to the client. So this is the procedure for the proxy design pattern, virtual proxy. And the remote proxy. Remote proxy provides a local representative for an object that resides in different address space. For example, if the actual data or actual object present in the various address spaces, the client doesn't aware about those things. The client knows there will be some object that will be served when we raise a request. So here the proxy object would handle those things. The proxy object would get the object from the better address spaces for the particular request. And then protective proxy. Protective proxy controls access to a sensitive master object. For example, I have already explained about this example in the previous video. If you're studying in college or some other institutions, you would have some lab session, and during those lab session you can access the internet. If you are trying to access social websites like Facebook, WhatsApp, like that, using your college or your institution network internet, then there will be some proxy server which won't allow you to access the Facebook server or WhatsApp server. Here this is acting as a protective proxy, is protecting the actual request based on the various criteria. So we will try to relate this with the real life example. This is the best example according to me for explaining the proxy design pattern using real life example. For example, consider there is a person named John. He is trying to get 500 rupees from his account. So he is having an account in XYZ bank. So what he do is he would have two options to withdraw 500 rupees from bank. The first approach is visiting the bank. This is the first approach. In the first approach, what he would do is he would try to visit the bank, and then he would fill the challan, withdraw challan, and he will try to hand over that withdraw challan to the cashier, and that cashier would check the credentials, whether the account number is valid or not, whether the sufficient funds are present or not, like that. After that, that cashier would return 500 rupees to John. This is the first approach. Here John is spending money as well as time for withdrawing 500 rupees. For example, consider John is residing at location A, bank is residing at location B. The distance between A and B is 5 kilometers. To cover the 5 kilometers, John is traveling using bike. So for that he needs to fill some amount of petrol. For that he needs to spend some amount of money, and then time. So to travel 5 kilometers, it would take some time. So by using the first approach, John is spending both money and time for withdrawing 500 rupees. This is the second approach. This is the second approach where John visits the nearest ATM, and then he uses the bank debit card and he swipes that debit card in the ATM machine, and he enters the required credentials like PIN number and other stuff, and is entering the 500 rupees in the withdrawal category. Here that ATM machine will act as a proxy object. It will try to communicate with the real object called bank, and it will check whether that account has sufficient balance, and it will check the other credentials, and the bank real object will reply those information to the actual proxy object, and that proxy object would serve the data to John. Here the proxy object is playing the major role behind the screen. This proxy object is handling the request on behalf of us. So by following the second approach, John is saving both time and money, because nowadays ATM is present on every street, so he could save both money and time to withdraw 500 rupees. So in real life we are using the proxy design pattern at every point of our life. In software applications also we are following proxy design pattern for some use cases. So you need to first analyze the use case, and you need to check whether that use case could be fit with the proxy design pattern or not. So these are the things about the proxy design pattern. If you want to learn more things about the software design pattern, then you could buy software design pattern book. The book link would be present in the description box of this video. So thanks for watching this video.